A pentagonal lamina of edges 25 mm is resting on HP with one of its sides, such that the surface makes an angle of 60 degrees with HP. The edge on which it rests is inclined to VP at 45 degrees. Draw its projections. So first we need to understand, first we want to check whether it is to be started from the front view or it has to be started from the top view. In other words, it has to be started from the vertical plane or it has to start from the horizontal plane. So first we should look at the angle of inclination. We can see here the angle of surface inclination is given with respect to HP. Since the surface inclination is given to the HP, so we have to start from HP. So initially, since he says the pentagonal lamina of edges 25 mm, that means it is the true length. Since it is the true length, that means all the sides has to be have true length. To have all the sides to be having the true length, that is we have to start from HP, then all the sides has to rest on HP. If all the sides has to rest on HP, then only it will going to be the true shape in the horizontal plane. Because the surface inclination is given with respect to HP, you make that surface parallel to HP. That means the surface makes an angle of 0 degree with respect to HP, in other words. So since he says one of the sides is resting on HP, you make the edge which is resting on HP has to be perpendicular to VP. So initially we can see that is the reason why in the top view, if you see, when you look from the top view, we can see one of the edges is in perpendicular to VP. So once we get the perpendicular to VP, then from this we can write the pentagon wherein each side will going to be having 25 mm. So here A, B, C, D, E. So here A, B, B, C, C, D, D, E and E, A, all the sides here are parallel to HP. That is A dash, B dash, B dash, C dash, C dash, D dash, D dash, E dash and E dash, A dash. Now when you are looking for the position, if you see AB is parallel to HP and inclined to VP, BC is parallel to HP and inclined to VP, CD is parallel to HP and inclined to VP, and DE is parallel to HP and inclined to VP, AE is parallel to HP and perpendicular to VP. So this is how you will be able to analyze this. And when we look from the front view, we can see ABC is near to the observer. So A dash, B dash, C dash is visible. D and E is away from the observer. So D dash and E dash will be in bracket. Now, since it is a black shaded portion, so that means it is a surface. So totally it will going to be a surface which is parallel to HP and perpendicular to VP. So that is the reason why you are getting a line in the front view. Now when you look for the 2D analysis, when you are looking in the orthographic view, we can see here the pentagon, one of the edges is made perpendicular to VP because that is the edge which is resting on HP. Once you get this resting on HP, then we can see the surface which is parallel to HP. All the sides are parallel to HP. So that is the reason why we are getting the true shape in the horizontal plane. In this case, one side will be a side and the opposite to that side will be a corner. Always in the odd number of sizes, one end will go to be a side and the other end will go to be a corner. So when you look from the front view, A, B, C is near to the observer. So A dash, B dash, C dash is visible and D and E is away from the observer. Therefore, D dash and E dash will be invisible. Then which one of the sides such that the surface makes an angle of 60 degrees with HP. So here in the second position, as we see, one of the side is resting on HP. The edge which is perpendicular to VP is the side which is resting on HP, because when you look from the front view, in the front view you are going to get a point. So that is the reason why we are considering this as the initial position. So here the surface initially it was 0 degree with respect to the HP. Now you made 60 degrees to HP. So that means when you are this entire surface, when you look from the front view, the inclination will be seen in the vertical plane, and here the surface is inclined to HP and perpendicular to VP. Since it is perpendicular to VP, so that is the reason why you are getting a line in the front view. And here we can see when you look from the top view, this is the projected surface A, B, C, D, E, and the points which are B, C, D, which is in capitals, is in the space. So when you look from the front view, B and D, ABC is visible, so A dash, B dash, C dash is visible. D and E is away from the observer, so D dash and E dash becomes invisible. So here also we can see that when the edge, since it is resting on one of its sides, the side is resting on HP and drawing an angle of 60 degrees, then to this we will going to write the top view. So in the second case, we can see the surface is inclined to HP. The inclination with respect to HP can be seen in the vertical plane, and when you look from the top surface, you will going to get the pentagon, which will going to be reduced in shape, so that will going to be the apparent shape. And since the side is parallel to HP, therefore you are getting the true length here, so that AE what we have here will going to be in the true length. Then in the third case, the edge on which it rests is inclined to VP at 45 degrees. So he has given the true inclination, and here the side which is resting on HP has to be in true length. Now you can see the side which is parallel to HP, you are getting the true length. So on the true length we have to have on the true inclination line we have to have the true length. So here the second position top view is also in true length, and the inclination given is also true inclination. Therefore, you rewrite the second position top view in the third position by rotating at an angle of 45 degree directly. Then to this we write the front view. So that is what we have shown here. You make the second position top view has been rotated such that it will be inclined at 45 degrees to VP, and to this we will going to write the front view. So this will going to be the final view of this. So this view and this view will going to remain the same, and this view will going to this sketch and this silhouette will be one and the same. So this is how we can be able to make 3D and 2D analysis. How to identify that our problem is right? We can see that the side which is resting on HP is inclined to VP at 45 degrees, and it is one of the pentagonal surface, one of the pentagonal side is resting on HP, and the surface is inclined at 60 degrees, and this is the side of pentagon having 25 mm. So since all the conditions have been considered here in the problem for the solution, and hence your problem will going to be right. So this is how we can make the 3D and 2D sketchbook. So to do that, so first we will going to draw the XY line and mark XY and VP and HP. So since one of the sides is resting on HP, you make that side perpendicular to VP. So draw a vertical line of 25 mm which is perpendicular to the XY line. Then mark this point as A and E. So from E through A with respect to AE, by using the protractor, you measure an angle of 108 degree, which is going to be included angle. If it is an exterior angle, the exterior angle will be from this point to this vertical line. So you measure 72 degree and then draw an inclined line. Similarly with E as center, by using the protractor, if you are measuring an exterior angle, then it will going to be 72, that is from here to here. If you are taking the included angle, then it will going to be 108 from here to here with respect to the vertical line AE. Then draw this inclined line. Then by using the compass, you measure the distance of 25 mm with A as center, cut an arc on this 108 degree line, and similarly with A as center, cut an arc on this 108 degree line, and you will going to mark this point as small b and small d. So similarly with this point as center, again take the 25 mm radius and draw an arc. Similarly with D as center, cut on by taking the radius of 25, cut on the previously drawn arc. So to get this point C, then join A to B, B to C, C to D, D to E, and E to A. Now we need to write the projections. So from the top view, draw a vertical projector from A and E to the XY line. Similarly from B and D to the XY line, and also from C to the XY line. And as we see from the front view, A, B, C are near to the observer. So A dash, B dash, C dash is visible, and D and E is away from the observer. Therefore, D dash and E dash will become invisible. And then join between A dash to B dash, because visible to visible is visible. Similarly, from B dash to C dash, again it is visible to visible is visible, and draw a dark line. So now, as we see from the first position top view, wherein AE is perpendicular to VP, so this end will going to be a side, and when you look from the top view, this point, this right end will going to have a corner point, so this side will going to be a corner. Now considering, since one of the sides is resting on HP, so the side which is perpendicular to VP has to rest on HP. So consider any distance, any convenient distance between the first end position of the front view to the second position, and mark the point as A dash and D dash. Then by using the protractor with respect to the XY line, you measure an angle of 60 degrees in the counterclockwise direction and then draw an inclined line. So by using the compass, you measure the distance from A dash to B dash from the first position. With A dash as center, cut an arc on that 60-degree line. Similarly, with A dash as center, take the radius of A dash C dash from the first position front view. With transfer the same distance from A dash to on the 60-degree line, and you mark this point as C dash, and you mark this point as B dash and D dash in bracket. Then join A dash to C dash with a dark line. Then now we need to write the second position top view. To do that, so first you draw a vertical projector from A dash and A dash to the top view. Then draw a horizontal projector from A and E. Both will going to intersect at these 2 points, and mark this point as A and small e. Then draw a vertical projector from B dash and D dash. Similarly, draw a horizontal projector from B and D. Both will going to intersect at these 2 points, and mark these points as B and D respectively. Similarly, draw a vertical projector from C dash and draw a horizontal projector from C. Both will going to intersect at these 2 points, and you mark this point as C. Then join A to B, B to C, C to D, D to E, and E to A. Then the edge which is resting on HP has to be inclined to VP at 45 degrees. So the inclination given is the true inclination, as we see here in the second position front view, as A dash E dash is resting on XY line. So that means it is parallel to HP. Since it is parallel to HP, so we are getting the true length on the HP. So now the AE, which is in true length in the second position top view, and the inclination given is also true inclination. Therefore, we reproduce the second position top view in the third position. To do that, first consider any point and mark that point as E, and from that point you draw a horizontal line. Then by using the protractor, then with E as center, with respect to the horizontal, you measure an angle of 45 degrees and draw an inclined line below the horizontal line. Then by using the compass, you measure the distance from E to A, and from E transfer it down that 45-degree line. Similarly, with E as center, take the distance from E to this point and transfer that from E to get this point. Then since this line is perpendicular to AE, so from this point, by using the protractor, you measure an angle of 90 degrees with respect to EA, and then draw a perpendicular to that EA line. Similarly, you measure the distance from this point to C. From here, you cut an arc on that perpendicular line to get this point C, and you mark the point as C. Then by using the compass, you measure the distance from this point to this point, and similarly you transfer from this point to here. Then through this line, since this vertical line is perpendicular to this horizontal line, so through this inclined line you take this as the center. Now you measure the distance from this point to this. From this point you transfer it on here, and once you get this point, so this line is perpendicular to the line drawn from C to the perpendicular to AE. So from this point with respect to C and the line which is perpendicular to EA, through this point you draw a perpendicular to this inclined line. Then by using the compass, you measure the distance from this point to D and also from this point to B. Both will going to have equal distances, and transfer it from this point to D on the top side and this point to B in the bottom side. Now you mark the points as A, B, C, D and E. So then you join A to B, B to C, C to D, D to E and E to A. Now we have reproduced the third position top view. So to this you need to write the front view. So draw a horizontal projector line from A dash and A dash, which is the XY line, and draw a vertical projector from A and E. Both will going to intersect on the XY line. Similarly, draw a horizontal projector from B dash and D dash, and draw a vertical projector from B and D, both will going to intersect at these 2 points, and you mark this point as B dash and D dash. Similarly, draw a horizontal projector from C dash and draw a vertical projector from C. Both will going to intersect at this point, and you mark the point as C dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, and D dash to E dash, and D dash to A dash with a dark line. So this is how you will be able to write the solution in the sketchbook. To understand or to analyze whether the problem is right, so this side, a pentagonal lamina of 25 mm side is resting on one of its sides on HP. So the side is resting on HP such that the surface makes an angle of 60 degree with HP, and then the side which is resting on HP is inclined to VP at 45 degrees. Even in the end position, we can see that the side is resting on HP. Since we have considered all the conditions have been satisfied by considering all these conditions which is given in the problem, hence the problem